Hi, Henry. So it's 3:45. I will get started right now. So I will start share my screen. Okay. So for today's lab, we are going to start our lab 4. For lab 4, the title is mapping VGI. And in this lab, we were going to map two available data on restaurants in Athens, Clark County using two VGI-based datasets. The first one is the dataset collected from the survey in the class, and the second one is the restaurant points we downloaded from OpenStreetMap. By comparing these two, we will be able to evaluate how representative each data is. And more specifically, in this lab, we will get experience in lab doing basic point pattern analysis. So we will generate a quadrant grid, and we will counting points within each grid cells, and then identify and comparing spatial patterns. So for the lab structure, we have two main sections in this lab. The first one, mapping our reviews. So we will add a base map using quick map service, and then creating a hexagon sampling grid. And then we will add our restaurant's review data, counting and mapping points. And then we will make a final print map. For the second part, it's pretty similar to part 1, but instead of using the restaurant's survey data we collected from the class, we will download and use the data from OSM, the OpenStreetMap, and then make a final print map. There's 4 data sets in this lab, and there's 4 data sets, and we will provide you 3 data sets with different grid cell size. So the 3 data sets are vector layer of different size grid cells, and you will need to pick one in your analysis. And then we will also provide you a geopackage file with our restaurant reviews data collected from the class survey. So let's get started. Oh, before we get started, we need to download the data, and all the 4 data sets I talked about should be already compiled in a single zip folder. So you will just need to download the Lab4 data. Click download. And then in your download, just move it to your own working folder. No, this one. And then you need to unzip that folder. Once you unzip that folder, you should see the 4 data sets I talked about. The first 3 are 3 different size grid cells and another point layer of our restaurant survey locations. So now let's get started. So as usual, this lab we will use QGIS. So just go to your start menu and search QGIS, then open it. It takes time to load. Sorry, it's a little bit too slow.
All good.
Okay, it's here. So we finally open this QGIS. First, let's load our restaurant review data. So go to layer, add layer. It's a vector layer. It's point layer. So it's a vector layer, and then click add vector layer. Click the three dots and just browse to your dataset folder, the unzipped data folder. Click the restaurant survey locations, geopackage data. Click open and then click add. And now you should be able to see all the restaurant review points added to our project. If you right click this layer, open attribute table, this is what this point layer looks like. So we have ID and we have restaurant name, restaurant address. So when we collect this survey, when we do this survey on our class, students might submit duplicate points. So for example, Calientito is really popular. We have 8 Calientito points in our final submission. So here we compile that data a little bit. So now each restaurant only show here in this attribute table once, but instead we add another column called point count. So point count shows how many how many people add reviews in the survey for that restaurant. So for example, yep, here, so 4 students submit the review of the grid, so the point count is 4. So that's the point count, and we also have XY coordinates. So that's our restaurant survey data. And then we're going to add a base map. So to add a base map to our map, we're going to use a plugin. As I said, I think the first lab or second lab, QGIS is a open source free software. It has lots of built-in functions. Also, it has lots of extensions, or we call it plugins. So we can accomplish more functions using the plugins. And in this case, we will use the Quick Map Service plugin to add our base map. So to do that, we will first install this plugin. So you will go to how to install plugins. You will go to plugins menu, manage and install plugins. And then under all, you just search the name of that plugin. So it would be Quick Map Service. Because I already installed it, so you can see it's already there. But what you will need to do is just click that Quick Map Service. And then here it would be install plugin. And instead of upgrade plugin, it should be install plugin. And you just click install plugin. And then once it's installed, you should be able to see it in the installed tab. So in my installed tabs, I have Quick Map Service. And then you can close this window. So there's then once you install these plugins, you should see you have 3 icons show up here in your QGIS. Those are icons for buttons for Quick Map Service. And if you click this button with the globe, and a little add button on the lower right. So this is the one we use to add base map. So if you click that, and then here you can see a list of different base maps. We have Landsat, map surface, NASA space map, and OSM. OSM is short for OpenStreetMap, and this E-Atlas. And then if you scroll to OSM, we're going to add OSM standard base map to our map project for this assignment. So this is how you add, this is the place you can add OSM. There's another place you can do that is you go to the top menu bar, you go to Web, and then go to Quick Map Service, and then it's similar. Just go to OSM and then click OSM Standard. So once you add the OSM Standard map to your project, you should see this base layer, and then you need to zoom your layer so you can see pretty much the whole 10 loop area and also the points. So make sure zoom out on this map until you see all of Athens, at least the area inside the I-29 loop. So basically this extent. And then we need to change our coordinate system. So the base layer we add is OpenStreetMap. OpenStreetMap is a web-based map, and most of the web-based maps work best or visualize best with Web Mercator, or we call it pseudo Mercator projection. And the code for it is 3857. So we will use 3857, these pseudo Mercator projections in our data frame. So go back to our QGIS, go to the bottom right corner, click that, and then just search for 3857, and then you should be able to see the pseudo Mercator, WGS84 pseudo Mercator projects. And then click apply, and then click OK. Now you should see your EPSG 3857 in the lower right. Any questions so far?
Nope.
Okay,
All
great.
good.
Great. And then next, we are going to create a sample grid. So as I said, one of the goals for this assignment is to do a point pattern analysis. And when we do point analysis, we usually aggregate points into different area units. And in Lab 3, we did similar things. We count number of points in each county, but we use county administrative units, administrative boundaries. For this lab, we're going to create our own customized grid cells. So those grid cells are uniform size and specific. We will create a hexagon grid cells. So something looks like this. These regular grids, we also call it quadrats. It provides a systematic and uniform way to aggregate point data. And to generate a quadrat or those grid cells in QGIS, we will need to use another plugin called QGIS. So similar to how we install and add Quick Map Service, we will install these plugins and use that plugins. So let's go back to QGIS. So go to plugins, manage and install plugins. Here on the all, you just search the name of that plugin is QGIS. I also already have that one installed. So once you search QGIS, you choose that, under the list, and here you should have a button called install plugin, and you just click install plugins. And once it's installed, you should be able to see it under the installed plugins one, under the installed tabs here. And once it's successfully installed, we will need to close this window. And now you should notice that we have a MMQGIS menu in our top menu bar. It has a bunch of different functions, and the one we need to use is create grid layer. So go to MMQGIS, go to create, and then go to create grid layer. Here, for the geometry type, if you click the drop-down menu, we have different options. Here we are going to create hexagons. So click hexagons, and then here the X spacing and Y spacing and units specify the size of your unit, for example. So if we go back to here, this grid has lots of hexagons. Basically, we're using X spacing and Y spacing to determine the size of this single unit. And then if we go back to QGIS, we will change our units to degrees. And then for the X spacing here, just to try it, we will use 0.003 degrees for now, and see how it looks like. Once you change the X spacing, Y spacing should be changed accordingly, and make sure your unit is degrees. And then it's the extent. So here, if you click the extent, it has several options. So one option is current window. So it will create a grid cell that covers whatever extent you have in your current window. So here it would be cover most of the Essex Clark County area, like whatever you showed here in this QGIS project window. Or you can do layer extent. So they will create the grid cells based on the layer, the extent of your layer. But here we have a base map layer, the OSM standard layer, and that layer is, or the extent of that OSM standard base map layer is worldwide. So that extent would be the whole world. And also we have the whole world options for extent, and also a custom area. So if you choose custom area, you will need to determine the extent here using left X, right X. So put your customized coordinates here. For this lab, we're going to create the grid with extent of current window. So we just need this much. We just need the extent of Essex Clark County area. And then for the output file name, you click the three dots. So that's where you determine the output file name and where you stored it. So I will just go to my working folder. And just give it the name, for example, grid 003. And then you can save it as shapefile, GeoJSON, GeoPackage. So GeoJSON is similar to GeoPackage. They are shapefile, GeoJSON, GeoPackage. They're all formats of vector layer. So I will choose GeoJSON for now. And then I'll click Save. Once you have everything specified, you can click Apply. And then close. And then you can see we have this hexagon grid created. So if you can't see the point, because now the grid layer is in the top layer, you can just move the point layer on top of that grid layer, so you can see where the points are. Any questions so far?
I don't think so.
Okay, let's just move on to the next part. So notice that the grid we just create is 0.00 degrees as the grid cell size. So that's just a test. That's just a try to how we use create grid functions in MM QGIS. And ideally, when you are doing your own research, those grids, it's critical to have a proper grid size. So this grid should be large enough that show a meaningful pattern. So basically, you don't want the grids to be too small that there are like only several points, 1 or 2 points falls within each grid. Also, you don't want the grid unit to be too large that almost all the points falls within 1 or 2 grids. So play around with the size variable and see how basically the X spacing and Y spacing, and see how it changes the grid cells. So you can play around with it more using QGIS. But next, we're going to count and mapping points. So similar to Lab3, as I said, in Lab3 we count number of tornado origin points in each Atlanta metro counties. Here we're going to count the number of restaurant survey points in each grid cells we created. But instead of create our own grid cells in this lab, we have already provided 3 grid cells for your analysis. So the 3 grid cells are sized at 0.01, 0.05, and 0.005 decimal degrees. And here you need to pick one you think is best or appropriate for counting the restaurant points. So let's just add those 3 to our QGIS right now. We're not gonna using this 0.003 grid cells for the following labs. So I will just remove it from my table of contents right now. And then we're going to add the 3 cells we already created for you. So go to layer, go to add layer, and add vector layer. So we will start from the largest, the one with 0.05 decimal degrees. So it's grid _ 05, this GeoJSON file, click open, and then click add. Oops, I accidentally add 2. I'll just remove the duplicate. Okay, so this is how the 0.05 decimal degree cells looks like. This is really big. If we move the points on top, you see all the points falls within 4 cells. And then we're going to add the middle size one, add layer, add vector layer, click the 3 dots. And then we're going to add this one, grid. So the grid cells with 0.01 decimal degrees. Click open, get, and close. This looks a little bit better. So the points was inside several cells, and then we are going to add the last one, the 0.05 one. Both are hexagon cells with 0.005 decimal degrees. Click open. Okay. Close. So this is the smallest one. So here, basically, you just need to see how the points interact with those 3 different size grids, and pick one that you think that can best aggregate our restaurant's points. So here you need to make your own choice. And after you pick the purple size grid cells, we're going to use the count points in polygon tool to count the number of points per grid cell. So you guys should be familiar with that tool because we've used it in Lab 3 already. So for demonstration purpose, I will use the grid 0, the medium size grid. So I will remove the other two layers I don't want for right now. Remove layer. Okay. Then I'm going to, before I go to the count points in polygons tool. Any questions right now? Any questions so far?
No.
Okay. So go to vector, go to analysis tool, and count points in polygons. Since we want to count how many points per grid cell, so the polygons would be grid 0, 1. In my case, in my demonstration, it would be grid 0, 1 grid cell size. And the points would be our restaurant survey locations. And then the count field name is num points. I will just use this default one. And then for the count, for our output file, I will click the three dots, and I will save to file. So instead of save it to temporary file, I will save it to my own folder. So I will save it as in job package format, so probably grid 0. Class restaurant. Click save. So once you specify the output file, you can click run. And now you can see the new layer is just added to our table of contents. If you right click this new layer, go to attribute table, you should see we have these num points columns, new columns added to our attribute table. And if you double click sort it from the largest to the lowest, you can see the grid cells that has points falls within it. But most of the grid cells you can see it's empty. There's no point falls within it. So we can close that. And now you can uncheck the original grid 0, 1 layer, or you can just remove it. Next, we will visualize those results. So to visualize the results, we will, for our output grid layer, we will symbolize the num points variable you just created as a choropleth map or a heat map. You may want to make this map semi-transparent because we, so for now, the map is not transparent at all, so you cannot see the underneath base map. So we want to make it a little bit transparent so you can see the underneath OSM standard base map. And then you can delete grid cells without any points. So let's just do that. To do that, right click the output layer, click properties. Under symbology, we will choose graduated. So you guys should be pretty familiar with this. Under variable, we will choose num points. And for the color ramp, you can choose a color ramp you like or you think best fits the data. I will just use the default red one. And then under the mode, you will need to choose a classification scheme. For demonstration purpose, I will use natural breaks for demonstration. And once you're done, you can apply. Now you can see hexagons are styled based on the color scheme we choose. And then we also want to make this layer semi-transparent. So to do so, under symbol, click the drop-down menu. Here under this color circle thing, we have this slide bar. In this slide bar, you can adjust your transparency. So I will just move it to the middle, then click apply. Now you can see my layer is semi-transparent and I can see underneath base map. Then you just click OK. So this is what is our map look like. And we will also deselect those hexagons that has 0 points in it. So to do that, you will just in your table of contents, under the legend of your layer, just uncheck the white one with 0 to 0, which means they have 0 points in it. Uncheck that. And then you only keep the hexagons with points within it. Any questions so far? Any issue?
Nope, everything's good.
Great. Then we will also use graduated symbols to symbolize the number of reviews for each restaurant. Like as I said, so the point count variable in our restaurant review layer shows how many reviews we got for that restaurant. And basically restaurants with more reviews would get a larger symbol. So to do so, we will just do it in here. So go to our restaurant locations layer, right click, go to properties. And then instead of single symbol, we will use graduated side symbol. So choose graduated. And then under method, we're not using graduated color. Instead, under method, we need to choose graduated side. So here from the drop-down menu, you choose side. And you can also see the screenshots here. And for the value, it would be the point count. So how popular that restaurant is among our class students. And then for the mode, you need to choose a classification scheme. So natural breaks, for demonstration purpose. Okay. So basically, for demonstration, I will break it into 4 classes. And also, you can change the symbol color here. So, for example, you can choose blue and whatever color you like here from the drop-down menu, and click apply. And then click OK. And now you should see our points are added to our map with different size. So the bigger the size, the more popular the restaurant is. So that's the what we need to add it to the map. Last, we will use a print composer to create a version of this map with an appropriate title and legend and save it as an image for your final submission. Also, in the final map requirements, you can see the maps should have relevant points. And for specific for restaurant review points, it should be sized by the number of reviews, the point count variable, a heat map or complex map showing the count of relevant points by grid cell. The grid layer should be semi-transparent. We already did that. And the map should include informative titles, scale bars, and legends. So now we're going to make the final print layout map for this class restaurant survey data. So go to project, go to our good friends new print layout, and then just give it the proper name you want. For example, class restaurant survey data. Okay. Here in the print composer, first we will add the map. So click the button to add the map. So the sixth button, just draw a purple side rectangle. Okay. So here you can adjust your map size by changing the scale. For example, I will change it 100,000. You can move the map within the map box. Here, I suggest you to write down or remember the scale you used for this map, because in our part 2 next week, we are going to create a similar map like this, but not using the class restaurant survey data. Instead, we will use a OSM restaurant data that we download from OpenStreetMap. But finally, in the deliverables, we will need to compare and analyze these two maps. So when it comes to comparison, it would be better if you can have two maps with the same scale. So that's easy for comparison, but that's just a suggestion. Any questions so far?
No.
Okay. Then we're going to add the required map elements to this map. So it will be title, legend, and scale bar. So first, let's add title. So click the text button, draw a proper size box. And just here, you need to come up with a informative title. For demonstration here, I will just use typing title, and click the font to change the font style, and font size. And also don't forget to make the text alignment center and middle. So first, add a title. The title should be informative, tells what the map is about. And then we're going to add legend. So use the legend tool. The legend tool is under the text tool. Just click that, draw a properly sized box. And then under item properties, you can give the title, legend, and then uncheck auto updates, delete the layers that you don't want. And here, grid 01 layer, we don't need that, delete that. Also for OSM standard layer, we don't need that in our legend, so delete that. So here, you also need to change the title for each legend item. So here, the legend title is the layer name. So you need to change it to a more informative title here, item title here. So you can just change it by double click. So that's for our legend part. And also you can play around with it. So you can have you can change the font or font size for each legend item. And then once you're done with the legend, we're going to add the scale bar. So to add the scale bar, go to the scale bar tool. It's under the legend tool. Click that and just draw a box. Here for the scale bar tools, you can change the style by choosing different styles from the drop-down menu of the style, and then you can change the unit. Also, you can change the number of segments here. For example. So yeah, that's the basically what we need for this map. Then once you're done with this map, you can go to layout, export as image, close, and then go to your working folder. Just give it a name and save it as JPEG and click save. Once you're done, you should be able to find the map in your folder. And that's what it should look like, the basic layout. Okay, once you're done, save the layout. If you haven't saved the QGIS project, they will ask you to save the QGIS project first. So just go to your working folder and save it, maybe Lab4. Then click save. Yep. And that's all we have for today. Make sure you save your print layout and save your QGIS project. For next week, we're going to do the part 2, which is pretty much similar, but we will download restaurants data from OpenStreetMap. And then we will create a similar map, looks like this. Any questions? Any problems?
No, everything's good. Thank you.
Okay. If you don't have a question, then you're free to go. Thank you.
Have a good one.
You too.
Bye.
Bye.